All right, on to 9.8, part 3. We've already looked at we've looked at some data to figure out, is it linear, is it exponential, or might it possibly be quadratic? We have figured out already that if the range is an arithmetic sequence, then it must be linear. We have figured out if the range is a geometric sequence, then it must be exponential. Well, what about the quadratics? How can we figure out if data is quadratic? Well, one thing about that is when you start to think about your range values in a quadratic, you're going to start to think about whether or not the range is symmetrical. Remember that parabolas have this axis of symmetry, and so your outputs end up being mirrors of one another. There's a lot of symmetry going on. So you should be thinking about that at all times. But of course, we should start by looking at our elements in the domain just to make sure we have a consistent interval. And in this situation, we do. Well, we can see now that there is something happening here. This does definitely look symmetrical. I see some symmetry going on in my range. Let's just start by looking at those first differences. Let's see if we have a common difference. First differences is a fantastic way of looking at that. And we kind of work backwards from 0 to -2. Hang on, let me just make that appropriate. From 0 to -2, so 0, not -2, that's +2. So 0 minus 2, that's -2. So our first difference there is -2. And if I go this way, working backwards, 2 minus 0, well, that's +2. And if I look at the first differences here, if I have 8 minus 2, I have 6. So this is not a constant. So our first difference is not a constant. That means it is not arithmetic. On to the next analysis. Well, it's also not a geometric sequence. We can see that. So if it's not arithmetic and if it's not geometric, we need to go on to looking at the second differences. So what are the second differences? Well, that's when you take these values, kind of treat them as if they're your new range. It's my set of first differences, and now I'm going to go ahead and go from this point to this point. So I'm going to do 2 minus -2, that's 2 plus 2, that equals 4. And now I'm going to come this way, 6 minus 2, that equals 4. Oh my heavens. In my second differences, I have a constant. If there is a constant in your second difference, then the data is quadratic. That's going to help you identify that symmetry in the range. Last part of this is, well, how do I write the equation for that? And just remember this, that y equals ax squared. We can think about it this way. We have some fantastic data I can use to figure out what a is. I'll just use this ordered pair up here. When y is 2, 2 equals a times -1 squared. 2 equals 1a. Okay, a equals 2. So a equals 2 allows us to say y equals 2x squared. And that's our final answer.